Hello, we're having a go at some more processing programming today. I was originally going to do pointerlize, so I stuck that up as the name of the stream this time, but I think I want to do easing functions instead. They're a little bit trickier. I haven't double checked on them. We're going to be doing this just raw and see how that goes. At the moment we're still looking at the letter drop one, so let's save that, get it out of the way, and start up a new one. Remembering I'm in VS Code here instead of processing, because I want to be able to share, but we haven't quite, what's the word I'm looking for, ironed out all the bugs in terms of using the sharing, so I won't publish the URL this time, but that's why we're looking at a Visual Studio, a VS Code window instead of a processing window. And that means when I do this I have to do it slightly harder way. I need a new folder, and we will call it, for now we will call it easing. Oh, it always goes in the wrong place. Delete that folder. Where's the new folder? That one. Still learning how to do VS Code. Why are you back in there again? I don't want that. Escape, close. It's still in there. Close that. Processing. I'm going to do it in the file thing, because that's where I know how to do it. Okay, you'll just have to, I guess that's all part of the streamingness. I'm looking now for where I keep these, which is in my overflow. There you are. Streaming, processing, I want a new folder. Thank you, I know how to do that here. Alright, new folder appeared, and I can put a new file in here. So the same rules apply about calling the file the same thing as the folder, even though I'm using VS Code. And off we go. Void setup, void draw. Very nice. And put a point just to get it going. Let's make it an ellipse. I must get sick of watching me type the same thing over and over again, but so it goes. Ellipse width divided by 2, height divided by 2, 20, 20, that's standard ellipse, and make a size 600, 600, and let's run it to see if that works, if everything's hunky-dory. Nice, everything is hunky-dory. Slightly strange rendering there. So be it. I've noticed that the rendering's not quite up to scratch on the Linux version, but maybe we'll jump over to Windows one day. I also see you guys getting the screen sharing again. Alright, so easing. What the heck is easing? Let's see if I can find a decent demo to put up here. I found one the other day. Easing. This cheat sheet was nice. So easing is about normally about moving one thing from one place to another, or changing the size of something, which happens a lot, obviously, in computer programming, especially in animation. You see it all over the web these days. So changing something from one size to another, the simplest way to do it is to just take the one size, change it to the other. Let's do that. I mean, why don't we just do that? So I can show you exactly what I mean. If I've got void, int x, well, let's go with size. We'll do the size of the circle here. I think that's reasonable, but remember, size is a bad variable name because it's also a built-in function, so I don't want to stomp over the top of that. So for now, my circ size is 20, right? So when I draw my ellipse, it's circ size and circ size. So there might be a reason for, in this program, the circle to go from a small circle to a bigger circle. Let's say it happens when I do a key pressed. We'll make it jump back and forth. So for now, whenever any key pressed, and recall that the way processing is set up, that whenever any key is pressed, this special key pressed function gets called for us. It does all of that hard work. So we know that when a key gets pressed, I'm going to be at this spot in the code. Let's make the circ size 200. Simple. So now when I run that, I start with a circ size of 20, and when I press the button, boom, circ size of 200. So that's changing from one size to another. Easy, but not very appealing. That was harsh and unpleasant. We'd much prefer something to change from one size to another in a kind of smooth fashion. That's what we call easing. So the next thing I'm going to do is change this so that it switches back and forth between the two sizes, so that if I press the key again, it goes back to the small one. So to do that, I say if circ size is equal to 20, then bump it up to 200. Else send it back down to 20. So again, I've not got the keyboard shortcuts memorized yet. Got to work on that, don't I? We've changed this to a conditional, so there's two paths for this code now. In one path, which happens when the circle size is 20, we change the circle size to 200. The other path, which will happen every other time, the circle size goes back to 20. And because every other time means when we've set it to 200, we end up with a circle that bounces back and forth between the two sizes. Good. Might make that a bit bigger. You can see I've now kind of hard-coded these magic numbers in here. I'm still only using them once, but I'm using the 20 twice. So I should probably put those out so they're not magic numbers anymore. And that's, if you remember, I often, almost always, use capitals for my magic numbers. Makes them stand out as magic numbers. Because I might otherwise put them as consts and ask the compiler to deal with it, but I don't want to talk about consts just yet. So if it's small, make it large, otherwise make it small. And because those variables, that's just a normal variable. It's a normal variable called small, but I happen to use all capitals for it. If circle size is the same as whatever's in small, then make circle size the same as whatever's in larger, else set it back to small. All right. And again, we still use circle size here. Those other two are used just for the growing and the shrinking. All right, so the first thing to realize is that any animation has to happen over a period of time. Yeah. So I need to introduce a time concept here somehow. Processing gives us quite a bit of control over time, not exact precise control over time, but control enough that we can get done what we want. So it has a default frame rate, but we're able to set the frame rate. So I'm going to set my frame rate to 60 frames a second. Everybody likes 60 frames a second, right? That means this will draw 60 times every second. Now we won't see any difference when we run this. It was probably drawing at 60 frames a second before. Whoops, larger, that should just be large. It was probably drawing at 60 seconds before. But it means we now know exactly how many calls to draw will happen every second, 60 of them, which gives us a bit more control over time, because time is a really important part of animation. So let's say I want this circle not just to go boom to the bigger size. I want its size to change slowly. Well, how might I go about doing that? So the first thing I've got to realize is that there'll be at a circle size, I'll still have that, and I'll still have the small and the large. But I need to keep track of one more thing, which is, am I going from small to large or from large to small? So what I'm going to do is I'm going to introduce a target. Is it target that I want? Yes, it is. I'm going to introduce a target variable, okay, which will start with small. And what that is saying is, during this animation, this is the number that I'm trying to get to. Because an animation exists over a period of time, and that means there are going to be many calls to draw during that animation. And sometimes during the animation, the circle size will be a very long way away from where I want it to be. And sometimes it'll be very, very close to where I want to be. And by the end of the animation, it'll be exactly where I want it to be. So I've got to keep track of where I want to be to target. I just have to initialize it to something here. So I've initialized it to small, which is the same thing as what circ size initializes to. And that reminds me, I should move that down there so that it's now under the declaration and can use the magic number can go away. We can use the variable instead. So I've got a bit of control over time. I know the target that I'm aiming for. But if I just put target, sorry, so what I want to say is that when a key is pressed, the circle size shouldn't immediately go to that new size. The circle size should, the target should become the circle size, and then something else will have to happen. So no longer do I want to say circle size immediately goes to large. I want to say target now goes to large. And what that, now, so this will stop the change entirely on this version of the program, but it means I'm now keeping track of the current circle size and the size I'm aiming for. Don't know how this works on the picture. And the size I'm aiming for, and I've got some control over the time, so I can start to control my animation. What next? Well, what size should the circle be on any part of the animation? This is where easing comes in. So if I do a one where it goes linearly from the original size to the new size, it just kind of just evenly goes. That's a good way evenly to think of that one. Do they have linear on the picture? They don't. So if you watch that little red thing on the right on this web page, you can see that the ease in sign feels quite linear, but actually quickens up just after it starts. Starts slow and then quickens up. An ease out sign starts fast and then slows down. If we pick one more obvious, this ease in and out goes slow, fast, slow. So all of the fastness is in the middle. Quite an exponential one, very fast and then slows down a lot. This ease out and back goes past and then drops back. So these are all different easing functions we could use, but we don't even know how to write an easing function yet. But this is what I'm showing you, is that there's a basic one, a linear one, which they don't have an animation for, unfortunately. Annoyingly. They don't have an animation for the linear one. That's one where it will go from where it starts to where it ends just directly, equally the whole way. So we'll program that first, but then we can start to play with the other easings, and I can show you in some ways my guesses, because I haven't double checked any of this. I'm just working straight out of what's in my head, my high school maths, that kind of thing, to try and replicate these. Maybe we'll look some stuff up to see if we can find out how right we were. Certainly some of these I'm going to find quite hard to do myself. I would have no idea how to do an ease out bounce, but I do have an idea how to jump to maybe a quadratic easing, or that's a quintratic easing out. Exponential I might be interested in. But linear, let's start with linear. So this is one where, now on these axes, we've got a time and an x. So what they're saying is, as time increases, then the distance you are along your path increases as well. So on this one, as time increases in this direction, the distance you are along your path increases slowly at first and then faster, which is how you get that animation. So we need a mathematical function that as one of the parameters goes up, the other one goes up according to the easing we want. So if we're doing linear, we want one as one of them goes up, the other one goes up at exactly the same rate. So that function already exists for us in processing. Cool. It's called LERP, linear interpretation. Let's look up LERP. We're going to learn to program it ourselves, but whoop. Sorry, that's processing LERP, and there it comes. So LERP is a function that takes three parameters, an a and a b and a percentage, and then moves you from A to B according to that percentage. So what we want is for the circle size to be the starting point, the target to be the ending point, and the percentage to be how far along the animation we are. So I might make a new variable, right, which says, okay, let's use the LERP to calculate the, new size, whatever the size is now. And it's going to be a LERP, a linear interpretation, linear interpolation between the current circle size, the target circle size. But then the question is, what do I put in here for the percentage? On the first time round that I'm drawing this, I want the percentage to be 0. And then the second time I want it to go up a little bit and up a little bit. And when I'm finally finished my animation, I want the percentage to be 100. So how do I do that? Well, I'm going to have to keep track of how far along I am on my animation. Okay, so I'll make a new variable called time passed. How much? Well, should we call it time passed or frames passed? Frames passed. How many frames have gone past since we switched sizes, since we wanted the animation to start? So critically, we need that to start at 0. I'll just leave it there for now. So what we want to say is that if I've got 1 frame and I want my animation to go over 100 frames, then this thing should be 0.01. And if I've got 2 frames and I want the animation to go over 100 frames, this should be 0.02. And I can get that by doing frames passed divided by 100. So it's when it's 1 frame, I divide that by 100 and I get 0.01. Let me get rid of that in the background to see if that makes any difference to the screen sharing, which we'll definitely work on for next time. The circle size, target, and the frames passed. So this will give me the lerp, I think, that I'm looking for. We're just going to try it out. And then instead of drawing the ellipse with the circle size, I'm going to draw it with the new size. Yeah, let's give it a go. Okay, so I got an error. Unexpected token int, and it's here, where is it? Line 16. So it's there. Didn't like my int new size in the middle of a draw function. Because I forgot the semicolon. Can't convert from float to int. So lerp is returning a floating point number, and I'm putting it in an int. So let's change that to a float. Now that might cause trouble here, right? But ellipse can actually take floats in that position, so it doesn't cause trouble, I hope. There we go, we're running it. Now when I press my key, nothing. I've broken something. Let's try and work out what I've broken. Well, the first thing is I'm not changing frames past. It starts at 0 and it stays at 0. So let's fix that. How do we know when a frame has gone past? It's when a draw function is called. It's draws get called over and over. I'm calling those a frame. So frames past goes up by 1 every time we draw the function. Now we might get some animation. Try again. Oh, it jumped very quickly up. Oh, whoa, just keeps going. Okay, that's not what I wanted. And it went in big chunks, didn't it? Very interesting. I wonder what's going on there. So, what's happening here is that frames past dividing by 100 is being done as an integer computation, because frames past is an integer and 100 is an integer, and if you take 2 integers and divide them by each other, it will do it using integer division. And remember what happens with integer division? You don't get the floating point. So when I do 1 divided by 100, it just says 0. 2 divided by 100, 0. 3 divided by 100, 0. It just keeps saying 0 until I get to 100, and then it says 1. So it does a big jump. Know what I want. So frames past is going to have to be a float to force this to be a floating point computation, and I'll just change that to a float as well to make sure it's a floating point computation. Let's see how my animation goes now. There we go. So it jumped a bit there, and then started doing the easing, but it went way past where I wanted it to, and the jump is actually something to pay attention to. So why did it jump? Well, it jumped because I'm accumulating the frames no matter what, whether I'm in an animation or not. The animation doesn't actually start until I press the key. So let's now keep track of whether we're animating. So a Boolean animating, one of the things from Ruby that I love is that you can put a question mark on the end of a variable, and it's a great way of saying this is a Boolean that's going to contain true or false. But I can't do that in processing. So am I animating? It's a Boolean. So we start off with false. We don't animate at the start. When do we start animating? When one of the keys pressed, right? So if circle size is small and I jump to target large, then I say time to start animating. Oops, so I set the animating to true. And the other part of this equation is I only want the frames to go up when I'm animating. So again, I put an if statement in that says, look, only do this bit of code when that condition is true. So the frames passed plus will only happen when animating is true. So now I won't get that jump, I hope, at the start. Now notice that I always tell you what I expect from my program before I run it. That makes me look like a fool half the time, but it's a really important part of programming because you should have an expectation for what you're going to see, compare it against what you see, and when there's a difference, you'll be able to hone in on it more quickly. If you run your program without an expectation of what you're going to see, you have no idea whether you got it right or wrong. All right, so good. I didn't get my jump at the start. And I've got a nice smooth animation, but it's going on forever. Why is it going on forever? Because I never stopped this animation. The new size is always just whatever, and if the frames passed goes past the total number of frames, then so be it. So I'm going to introduce a new variable that tells me how long I want the animation to go for. And it's going to be in terms of the number of frames, right? So it's 100 because I want it to happen over 100 frames. Better make that a float just to make sure that the computation here happens the way I want. So now it's this here. Now it's frames passed divided by animation length. That gives me the percentage I am along my animation. What next has to happen? Next has to happen is that I got to stop the animation at some point. So the draw here has to decide not to make frames passed go up anymore. When I don't know when. Well, it's when the target, the new size, has reached the target. Right? If new size equals target, and I'm actually not going to use equals, I'm going to use greater than or equal to, and I'll tell you why in a minute. But if new size is equal target, if I've grown all the way to where I want it to be, stop animating, please. And in fact, do something else as well. Stop animating, and please just set the circle size now. Oh no, I should leave it that way actually, sorry. Just stop the animation for now. So I'm expecting the animation now to stop when it gets to the right size. Animation can't be resolved to a variable, it's animating. And we press the button and it grows and it stops. And it grew over 100 frames in a linear way and then stopped. Nice. If I press a key, it's not going back to the other size though, so let's see if we can get the bits and pieces we need for that. So if circle size equals small, we set up the animation. Well, there's one problem. I didn't say animating equals true down here for the other one. For when I press the key. Let's see if that does what I need it to. I don't think it will. I don't actually have an expectation of this. I'm doing this as an explore. Animation again. Animating. Press the key. It should go up to the right size. Press the key again. Nothing happens. Okay, that's all right. I didn't think I'd done everything I needed to. I'm setting the animation to true again. But up here you see the new size is target. And it stays because I forgot to change this to target equals small. So now the animator starts again, the target resets to small, so it's going to loop back around and the draw will run again. Now the new size has got two new values, but frames passed is still a very big value, so it's probably going to jump directly to the end of my animation. Let's see. So it grows on that one, and still does nothing on that one, so I've got some other problem that I have to deal with. Well, the circ size never changes. That's something to notice. This one here, this if circ size equals small, fires off at the start of the program, but I never change circ size again, do I? I'm going to have to do something harder in my draw function here. This new size, it's kind of a temporary slot that I'm using during the animation. And then I don't really want to use it after the animation anymore. So I probably want to change my draws function so it's got different flows, one for when I'm animating and one for when I'm not animating. I don't have that yet. Well, I do, but I'm only using a little bit in the animating one. So let's make that if animating kind of take over the whole draw function. We'll move more things into it. all the things that we do want to have happen while we're animating. Move it further up. So one thing we do only want to do when we're animating is this whole computation with the new size. That's only got to do with animation. Yeah, and then I'll draw an ellipse of new size only when I'm animating. When I'm not animating, so else, I just want to draw an ellipse of whatever the right size is. Something's going wrong with me typing size today. And is there anything else I want to do? So this guy here, I only need to do this during an animation, right? It only makes sense to check whether I'm still animating inside an animation. So if I've made it to the right size, then please change animating to false. But I want to do something else here as well. When I made it to the stop animating, I also want to finally update circ size to whatever I was going to, because the animating's finished now, right? And I'm going to jump down to this branch, which does absolutely nothing when I'm not animating. It just draws at the right size. And that also means that when the animation stops, I'll update the value of that global circle size so that maybe it won't be small when I get back down to this section down here. I'm pointing at my screen, but you can't see which bit I'm pointing at. So that when I get down here, that this one might not trigger off because I've updated the circle size. Okay, growing, shrinking, oh, and then immediately growing again. So that's not quite right, is it? Oh, and then growing forever. Something very strange happening. Let's think about it. So it jumped straight back down because I didn't set the frames past. And then it kept growing because I had an equals here. So it actually is more defensive in my programming if instead of saying new size is equal to target, I say anytime new size is greater than or equal to target, please just stop animating and go back to the size I was asking for. More defensive. And we'll deal with half of that problem. The other half of the problem is that once new size gets to target and we set animating to false, we've got to get ready for the next animation. And getting ready for the next animation requires us resetting the past frames. So we could either do that here when we stop the last animation, or we could do it here where we start the new animation. So I'm going to do it here because I think that's the right place. We're setting up a new animation to get going. We're saying I am about to animate. The target for this animation is large, and the number, so I'll have to reset the frames past so my animation can start again. I have to do it on both. And let's see if that deals with the fact that it jumped straight back down. So keep press up. Oh, it still jumped straight back down. Okay, but at least it didn't keep growing again after that. Press it again, grows, still jumps back down. Okay, what is going on there? Frames past is definitely getting reset to 0, so I wasn't expecting this bug. Circle size is set to target. Target is set to small. It could be that it's linearly interpolating negative numbers. It's jumping straight to circ size. So the circ size is updating immediately. Oh, it's because the new size is greater than or equal to target. Right? Because the circle was going to be shrinking. So my defensive programming was a bad idea here. My defensive programming, as soon as it saw that the new size, I wanted it to shrink, right? But it started animating and said, oh, your new size is bigger than your target, man. So I'll just stop animating and set it to target. Boom, straight down. I better go back to putting an equals there. So it's less defensive, and as soon as I do this, I think to myself, oh, actually, I might still have that problem come up, but I need to do it to fix this problem. Grows. Press again. Shrinks. Grows. Nice. There we go. Okay, now we have an easing animation. That took quite a bit to get there, and that's one of the things with animations is that there's a lot to keep track of, even just to get a simple animation going, but it's worth it. So we did that one using lerp, but I also want to experiment with some other interpolating functions here, some other easing functions. So the first thing I'm going to do is write our own version of lerp, which is not the simplest thing in the world. So lerp here has taken in a starting point, an ending point, and then how far along we are. So on the diagram here, we should think of that as taking in the starting point, the ending point, and how long across the t we are. I'm going to write my own version of that. I want to keep it on the screen so I can see it. So I'm going to put it, I'll just put it down the bottom. So this is, it returns a float. I'm going to call it mylerp. Well, let's call it ease. So in this case, lerp, linear interpolation, is the mathematical formula we're using to do the easing. Easing is the animation idea. So I want to ease from a start point. I'll put these down as floats just so that they're more general, to an end point, and how far along am I are the three things I know. And that how far is a number between 0 and 1. It's a percentage. But it's a percentage of the time, not a percentage of how far I want the animation to have gone. Well, this is quite easy. I just want to apply that percentage to the gap between them and then add that to the start. A linear one will just say, whatever, how far do you have to go? Well, you have to go from end to start. That's how far I have to go. Well, you should multiply that by however far you are along. So that's how much I am into my animation, but I didn't just start at 0, so I better add back on where I started from. That computation should give me the number that I want to return. And with functions, if all we're computing just sits in one line, we can return that line directly. We don't have to put it in another variable. So we're taking in 3 variables, we're doing a computation with them, spitting it back out, and we're hoping that it gives us the same thing. So now I'm going to move from using the built-in lerp function to my ease function and just see if I still get the same animation. And it looks like I do. That looks very much like the other animation. It can be hard to tell. We're going to try a couple of others now to see if... so now we've got complete control, so we can try a couple of others. So this ease function is linear. Let's comment that one out. We don't want that one anymore. Let's try another one. So the next one I want to try is called quadratic. So I'm expecting this one, a quadratic one will start slow and then speed up a lot at the end. And to do that, I don't use how far just directly. I multiply how far by itself. And one of the tricks with multiplying numbers between 0 and 1 by themselves is that the small ones, when they multiply themselves, they stay small. And the big ones, when they multiply by themselves, they get very close to 1. And 1 multiplied by itself is 1. So you get the picture they showed you here on the quad one. This quad one, you get a curve. So it starts off slower and then gets faster. Let's see if we can... So this is the animation we're going for, the ease in quad in this case. All I've got to do to get that is just, instead of using how far directly, I times how far by itself before I times it by the gap. Nice. Let's see if we can actually detect. Oh yeah, I think I detected that that went slow and then fast. Yes, definitely. All right, I'm going to mix this up now by putting 2 animations on so that we can compare the 2. All right. So I definitely saw that that was different, but I still want to try and show off more that it's different. Should we try one more? Well, let's do a what would we call this? That was a quadratic, which is times by itself. Then there's the ternary. What would you call the ternary one, where you do 3 times? Cubic. So we can do a cubic one, which does the same trick but makes the curve steeper. And to do that, all we do is multiply how far by itself again. Because that's what it's talking to with the quadratic and the cubic. It's talking about how many times have you multiplied how far by itself. All right. So now our easing function is a cubic. Fingers crossed. Very slow at the start and then ramped right up. Very slow and then sped up. Okay, I like it. Look, I think that's enough to demonstrate what I wanted to demonstrate. So if I wrote this down as a mathematical formula, that would be start plus how far to the power of 3 times gap. But that's a bit hard to write down in a program. in program we do the power of 3 out the long way. We could use a power function, but it doesn't make it any easier to read. All of these here, at least down to ease back. I think ease back and ease out back might also be functions. But most of these are just mathematical functions. If you write the right function in your ease, you'll get the easing animation that you want. These ones here look more complicated, don't they? It might be fun to look up and find out whether these can be done as functions or not. I know that they certainly can be done as functions, but is that the way they're really done in reality? You can make a function fit just about anything you want. It just depends on how complicated the function is. So I know how to do the linear easing. Now sine easing is a lot like the quadratic one, but instead of using powers to get the curve, it uses a sine to get the curves. It starts it off even slower and doesn't ramp up quite as much. We can do that with the sine function if we want. So all of these are relatively easy here, the ins and outs. But then exponential is relatively easy too. But yeah, 2 to the power of 0, 2 to the, yes, it's 2 to the power of how far in this case. Should we try that one out? I think that's what exponential is. So what I'm saying to you is this one is how far. Linear was just how far by itself. Quadratic was how far to the power of 2. Cubic was how far to the power of 3. Exponential, I think, is the opposite. It's right. Sorry, let me rewrite this one. This one is how far to the power of 3 times gap. That's basically what the formula was. With exponential, I think it's the opposite. It's 3 to the power of how far times gap. Okay. So I'm going to try and do that. But to do 3 to the power, it's like how far is a number between 0 and 1? I can't just do it by multiplying it out. I have to use the built-in function. So I'll do that. So start plus power 3 to the power of how far times by gap. Let's see if it lets me do that. So that power is a function built into processing that does one number to the power of the other number. Oh, there's not gap here. Gap is end minus start. Okay. Whooshka. I don't think that worked. That looks pretty immediate. So I've made a mistake there in how that one happens. I'll have to go learn about that one, won't I? I've got the... Yeah, that's just straight away going immediately up to the next size. So 2 to the power of how far. How far is the number between 0 and 1? So 2 to the power of 1 is 1/2, right? Oh, so 2 to the power of a small number, 0.1, is a very large number. So I've got my... maybe if I do something like this. You can see me looking up sideways because that means it still doesn't happen. That means I'm trying to remember some old maths that I haven't used in a while. So as always, we flew one too close to the sun. We don't know how to do that one without looking it up or doing some reading, but we do know how to do this one. Cubic easing. So that's your start on easing. I quite like this kind of stuff where a simple mathematical formula can be made visible, animated. Now we did have a bit of mucking around. I didn't get the chance to show you the two next to each other so we could compare the two animations, but you can imagine, I'm sure, how you can grow this program so that it draws two circles, not one, both of them animating at the same time, but using a different easing function to work out the size that they should be drawn at. Okay, that is all for now. I shall see you next week.